Hello, 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 ladies and gentlemen, and welcome back. Thank you for joining me as we take a look at question number 9 on the 2017 Euclid paper. A permutation of a list of numbers is an ordered arrangement of the numbers in that list. For example, 3, 2, 4, 1, 6, 5 is a permutation of 1, 2, 3, 4, 5, 6. We can write this permutation as A1, A2, A3, A4, A5, A6, where A1 is 3, A2 is 2, A3 is 4, A4 is 1, A5 is 6, and A6 is 5. Okay, introducing the idea of a permutation. Nice to have a good, clean definition there. So we got 3 parts to this question. The whole thing's written. A part, determine the average value of, we have absolute value, A1 minus A2, plus absolute value A3 minus A4, over all permutations of 1, 2, 3, 4. Okay. Looks like they're going to be using permutations more, so let's read the whole question and see if we can make a list of common notions of permutations that we'll need for these. B part, determine the average value. So it's again another average value question, but now we have no absolute values. A1 minus A2 plus A3 minus A4 plus A5 minus A6 plus A7, overall permutations of 1 through 7. Okay. And C part, now we're back to absolute values. Determine the average value of absolute values. So once again, we're subtracting pairs, taking the absolute value and adding up all those absolute values, but it looks like this time we're going from 1 up to 200. Okay. So, looks like A and B at least are related. They're all related by doing average values. Sorry, I said A and B. I think I said A and B. I mean A and C. A and C. The first and the third questions look related because they're both absolute values of differences of pairs. B seems sort of the odd question out. They all have average values, but B has no absolute values. Because you couldn't do absolute values of differences of pairs because 7 is odd. Alright, so I'm probably going to want to try and do A and C together. I mean, C is just using sort of 2n and then letting n be 100, basically. So we'll try and do A and B together, or A and C together, and then what to do for B. Okay. So we'll go to our notepad. So to do A and C together, and by no means does this mean we have to do A and C together. I mean, maybe the technique that works for A is just writing out all 24 permutations, whereas the technique for C is something different. But it's such a similar question, I'm inclined to believe we can do them together. So to do A and C together, consider the sum of A1 minus A2 plus A3 minus A4 plus all the way up to A2n minus 1 minus A2n. We need an even number of numbers total in order to be adding up differences of pairs. Note here we have n terms. If we can get a formula, and there's no guarantee that we will, but I think we probably could, you get a formula for the average value of this sum over permutations of 1 all the way up to 2n. So we can get an average formula. If we can get a formula for this, we solve A for n is 2, because A had 4 numbers, and we solve C when n is 100. So, if I can get a formula in terms of just n for the average value of this expression, this sum of absolute values of differences of pairs, then at the end, let n equal 2, that'll give me the answer for A. Let n equal 100, that'll give the answer for C. And then we'll just be left with B. Okay, that's my idea. I'm trying to sort of kill two birds with one stone here. Alright, well, what are we to do? We're sort of swimming in the realm of abstract, and maybe answering A part will give us a general idea as to how to approach this. But, So, I notice I have n terms. So, if I can, if we can determine the average value of A1 minus A2, absolute valued, overall permutation. I don't know whether or not they'd give me marks for that. So there is a nice result if you do probability, and I know probability isn't exactly on the radar in high school. But the average of a sum is just the sum of the averages. Now, maybe we need to use this result. I don't think, I mean, there's probably a way around it, but that's what I was going for there. Is if I just want the average value of the sum, I can just do the sum of all the average values, and it should be the same average value for each. So it would just be n times the average value of the absolute value of the difference of A1 minus A2 overall permutations. But maybe, okay, how do we normally compute average? Average is the total of, the sum of everything. So the sum of these sums all over the number of expressions. Now, this, how many permutations are there of 1, 2, 3, 4, all the way up to something? It's going to be 2n factorial. Okay? If you were doing something like 3, we were permuting 1, 2, and 3. You could do 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, or 3, 2, 1. These are the only ones. That's 6 of them. That's 3 factorial, which is just 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. 100 factorial is 100 times 99 times 98, all the way down to 2 times 2 times 1. So if you haven't seen factorials, first of all, you're probably going to have a bad time with this question number 9. Factorials are something you definitely should be seeing, or should have seen before attempting 8, 9, and 10 on a Euclid. But there's a very quick explanation as to what a factorial is. So I can very quickly get the bottom here. It's just the sum of all these expressions that's challenging. But whatever it is, we'll divide by 2n factorial. So there I'm starting to get n involved here. Although hopefully a bunch of things will cancel out. Okay. Oh, geez. I wonder if we're going to have to do... Okay, so consider any old A2k minus 1 minus A2k. Okay? That's actually... I believe they give that to us. Yeah, that expression. So consider any one of these different absolute value differences. So for any pair of integers, 1 less than or equal to I, j, and less than or equal to 2n with I not equal to j, there is some permutation. In fact, there's a bunch of permutations that take I to 2k minus 1 and j to 2k. So for any pair of integers, there are, I don't know how many, I'm going to leave that blank for a moment. that many permutations. Taking I, or with, we'll say with. A2k minus 1 equal to I, and A2k equal to J. Okay. So then this sum would be I minus J. Should I instead have this so that I can say that this is the absolute value of I minus J, which is really just J minus I? Maybe that's the expression I want. So how many permutations actually do this? Well, we have two numbers fixed, but then everything else, all 2n minus 2 other numbers can be rearranged freely around them. So that many permutations with this, and again another 2n minus 2 factorial permutations. With a2k minus 1 equal to j, and a2k equal to I. And in that case, a2k minus 1 minus a2k is equal to absolute value of j minus I, which again is j minus I. So j minus I appears in our sum at a2k minus 1. So it equals j minus I 2 times 2n minus 2 factorial times for a given k. So we considered a generic term in our sum for that fixed k and any pair I and j, with I less than j. And there's, how many pairs are there going to be for that? Well, we'll deal with that in a moment, but I think it's 2n choose 2, because once I choose them, the order is fixed. Also, we don't, if I is less than j, we don't need to say this now, do we? Alright, so then that's the number of permutations, because everything but those two numbers is fixed. Once again, everything but those two numbers is fixed, so we get 2n minus 2 factorial permutations. So we'll get specifically j minus I as the kth term in our sequence, in our series, 2 times 2n minus 2 factorial number of times. Now that's for a given k. Well, how many k's are there? There are n choices of k. So we have j minus I, specifically j minus I, not the value of their difference. So we're talking about 3 minus 2 is different than 4 minus 2 is different than 3 minus 1. The j and the I matter here. So we have that, a total of 2 times n times 2n minus 2 factorial. This, not so bad, because there's 2n, there's 2n minus 1 factorial. All we're missing is 2n minus 1. Get that as a factor in there, and then suddenly we've got 2n factorial. Okay. Now there are 2n choose 2 many choices of j and I. I don't know if we'll need this yet. Well, let's write what we've got. So my average currently as a formula is there's 2n times 2n minus 2 factorial times the sum of all these I less than j's, j minus i's. All over 2n factorial. Now I wonder, are we double counting? No, because we considered each term separately, so we should be fine there. Now this bottom part here can be expanded as 2n minus 1, 2n minus 2 factorial. So cancel, 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 cancel. So currently our average stands at the sum over all I less than j's, j minus I over 2n minus 1. So, okay, that's not bad. Can we simplify this top expression? I'm not entirely sure how to go about it. I'm going to split it up as j equals 2 up to n, and then the sum of I equals 1 up to j minus 1, sorry, of j minus I. But in this expression, j is a constant, so I can pull it out. So I can write the sum from j equals 2 up to n of j minus the sum from I equals 1 up to j minus 1 of I over 2n minus 1. Now this expression in here is just the sum of the first j minus 1 natural numbers, and I know a formula for that. And it's a common enough formula that we don't need to justify it. It's whatever number you go up to, that number times that number plus 1 all over 2. So this is j minus 1 times j all over 2. Okay, so now my average is the sum from j equals 2. Well, actually, yeah, j equals 2 all the way up to, I said n, didn't I, earlier? Yeah, should be 2n. Of j minus the sum of j minus 1 times j all over 2. No, that's not the sum. It's okay. What can we do now? I'm a little upset about this j equals 2 here. I feel like it should be j is 1, but then there'd be no sum. Because you'll never get j minus 0. Or you'll never get 1 minus 0. It'll never be 1 minus something. So I guess I'm okay with that. Okay. And this is all over 2n minus 1. 2n, j is 2. I'll do j, I'll write that as 2j over 2 minus j minus 1 all over 2. Over 2n minus 1. Kind of wish I wasn't carrying this 2n minus 1 around with me, but that's okay. Do the whole expression over 2. 2j minus j times j minus negative j should be 3j minus j squared. or 3 minus j times j. All over 2n minus 1. Okay, well I can take out the factor of 2 from the top. Put it down there. And I can write the top part now as 3j minus j squared. And I suppose I could separate out this sum here. So I can go from j equals 2 up to 2n of j, or sorry, 3 times that, minus j equals 2 up to 2n of j squared, all over 2 times 2n minus 1. Then, well, actually, this first bit here is just the same formula we used earlier. So it's going to be 3 times 2n times 2n plus 1 all over 2. But remember, we don't have j equals 1. So we'll subtract off 3 here. And then we don't have j equals 1 here either, so it'll be minus some expression minus 1. Now, what is the sum of the j squareds up to 2n? Well, there's a formula for that as well. It's k times k plus 1 times 2k plus 1 all over 6. Alright, because if you plug in 1 there, 1 times 2 times 3 all over 6 is just 1. Plug in 2 there. 2 times 3 times 5 is 30 over 6 is 5, and that is 1 plus 4. So the formula does work. So now I can get 2n plus 1 times 2 times 2n plus 1, so that's 4n plus 1 all over 6. Okay, so this should be my formula in n. Now let's clean it up a little bit. What can we do? The minus 3 minus negative 1 is really just negative 2. I can put everything over 6. So we'll change that to minus 12. All over 6, so that'll be 9. 2n times 2n plus 1. And then minus 2n plus 1, 4n plus 1, all over 2 times 2n minus 1. Okay, we can change that to 12 times 2n minus 1. Alright, so this, in theory, is my expression. Assuming I don't like this minus 12 here. I feel like this is wrong somehow. And I was expecting more things to cancel, frankly. But I guess that's it. I suppose what we could do is group these together. So we've got the factors of 2n and 2n plus 1 here, and then 9 minus 4n plus 1. Again, minus 12. I don't like that 12 there. So 9 minus 4n plus 1 is really just going to be 8 minus 4n. You can take out a factor of 4 there, so 2 minus n. Something like that. And then I can at least divide by 4s. So 4, that becomes a 3, that becomes a 3. So my average is currently looking at 2n plus 1, 2 minus n minus 3 over 3 times 2n minus 1. Okay. Well, I'd say that's probably good enough for our purposes. So for A, n is 2. So the average is going to be 4 times 5 times 0, minus 3, all over 3 times 3. So the average value of the sum should be negative 1/3. I don't think so. So something, somewhere, seems to have gone wrong. Okay. Because there's no way the absolute values ensure that it'll always be a positive sum. So what have I done wrong? So we got the sum of, I never used this 2n choose 2 stuff here, which is a shame. I'm happy with most of this. I'm happy with this part of the formula. I feel like when I went to go and simplify it, it caused problems. Now, if I just stick with this formula, in the 2 case, what would I have? I don't have enough space. So ignore all this, I guess. Average the sum of I less than j minus I, over 2n minus 1. I was happy with this. For n equals 2, what would we have? Well, we'd have 2 minus 1 plus 3 minus 1 plus 3 minus 2 plus 4 minus 1 plus 4 minus 2 plus 4 minus 3 all over 3. And I assume a whole bunch of things will cancel here. The 2 and this 2, this 3 and this 3. So we'll be left with negative 1 plus 3, which is 2, minus 1, which is 1, plus 4, which is 5, minus 1, which is 4, plus 4, which is 8, minus 2, which is 6, plus 4, which is 10. So I get 10 over 3, and that is a much more respectable answer for A part. Why didn't my formulas in simplification work? Okay, I see what I did wrong now. So I do still get minus 1, minus 2, minus 3 and everything. But I took out the j. I brought j out front, but it should have been multiplied by j minus 1 there. There we go, that's my problem. Alright. So, we'll continue on. Get the average there. All over 2n minus 1. So, sum from j equals 2 up to 2n. I'm still not comfortable with that 2, but who cares? Now we get the sum from I equals 1 up to j minus 1, j minus I. There are j minus 1 j's being added up here. So if I want to bring it out, because it is a constant, I can bring it out, I have to bring it out with all j minus 1 copies. Notice that there were 3 copies of 4 when we added up. So that's minus j minus 1 times j all over 2. Ooh, that's not a bad formula either. Okay, but this is just 2 times this. So our average is just going to be the sum from j equals 2 up to 2n of j times j minus 1 all over 2 over 2n minus 1. We'll bring the 2 down here again. And once again, we get j squared minus j, which I can split up to sum of j squareds minus the sum of j's over 2 times 2n minus 1. Now I can add in I can subtract off a 1 to increase this up by 1, and I can add on a 1 to include j equals 1 here. But aha, these guys cancel. So that should be fine. 1 minus 1, yeah, adding in the 1s didn't really do anything. And now I can use my formula again. 2n times 2n plus 1 times 4n plus 1 all over 6 minus 2n times 2n plus 1 all over 2. And all of that is over 2 times 2n minus 1. Okay, we can multiply by 3 here and put this 6, and now both 6's can go down to the bottom with this 2 and become 12. So I get 2n times 2n plus 1, and then 4n plus 1 minus 3, all over 12, 2n minus 1. But this is really just minus 2, and then this is really just 2 times 2n minus 1. So now this and this cancel. I get this 2 and this 2, and these 12s cancel to give 3. So n times 2n plus 1 all over 3 should be my answer. So the average value is going to be n times 2n plus 1 all over 3. So, and we already computed the answer to A, so we know it should be 10 over 3. So for n equals 2, this is going to answer A. We get an average value of 2 times 5 over 3. Hey, 10 over 3. We're all done. For C, that would be n is 100. Now we get an average value of 100 times 201 all over 3. 201 is divisible by 3. 2 plus 0 plus 1 is 3. So that's going to be 67. So our answer should be 6,700. So there, we did A and C together, although I admit if you had done A by some other means, even just writing everything out, you would have had this 10 over 3 and been able to verify your formula a little quicker, or at least gotten part marks in case time ran out and you didn't get this giant formula completed. But that's a nice quick little formula there. Okay, now, just because we've done C does not mean we're done the question. We completely skipped over B part in favor of getting a formula that knocks out both A and C at the same time. So let's go back and reread B. It didn't have absolute values because we weren't averaging over an even number. So we couldn't pair things up and do absolute values there. So B part, determine the average value of A1 minus A2 plus A3 minus A4 plus A5 minus A6 plus A7 over all permutations. Well, how many permutations are there going to be? 7 factorial, which is 5,040 if I recall correctly. Okay, well, how are we gonna do this? How are we gonna add up this? So this B part would actually be done really quickly if you used what I said earlier. Expected value is what we call an probability. But if you have, so here's what I would say is a shortcut method. I'm not going to use this. I'm going to write an actual full solution. But expected value, which is average, is linear in that we can just pull out these minus signs and everything. But each of these numbers, A5 and everything, is going to run through 1, 2, 3, 4, 5, 6, 7 in equal amounts. So they're all going to have the same average value. In which case, oh, this cancels with this, and this cancels with this, and this cancels with this. And so it's just the expected value of one of these, which should just be 1 plus 2 plus 3 plus 4 all plus up to 7 all over 7. Should be 28 over 7, so we should get an answer of 4, doing it really quickly with expected values. But I'm not going to do it because high school level contest, we don't usually talk about expected value in most high school curriculum, and I think I also would need to write a little bit of a justification as to why EA1 is the same as EA2 is the same as EA3. It's not going to be hard, but that would be something I should add in here. And also, I should probably explain a bit better how I calculated EA7 is 4 to get full marks. But there's my very quick, rough estimate. I think the answer should be 4. Let's see if we can get the answer slightly more properly. Alright, so there are 7 factorial, which is just 7 times 6 times 5 times 4, and so on, all the way up, all the way down to times 2 times 1, which is 5,040 permutations. A1 will equal, I want to say this a different way. So A1 will equal K. Now, AK will equal, I don't know, M in 6 factorial permutation. So we're doing the same sort of approach we had to A and C, in that we're fixing one of our terms and saying, oh, when can it be this specific value? Now, in A and C, we fixed one of those absolute value sums and said, when can that be j minus I? Well, we had to treat it all as a single term, whereas each of these AKs, A1, A2, and so forth, they're the single terms. So I say, when is A3 going to be equal to 4? Well, if I fix that as 4, the other 6 numbers can be assigned however we want. And that's just all 6 factorial other permutations, or permutations of 6 sort of letters or numbers in this case. So A3 will be equal to 4 in exactly 6 factorial of those 7 factorial permutations. Now 6 factorial happens to be 720. Okay. So that's what AK can be. So AK will be equal to M in this many factorial, in 720 of the permutations. So how do we compute average value? Well, we add everything up. All over the number of the expressions, which in this case is 7 factorial. Now, the minus signs make things a little trickier. So we'll get A1, I'm going to rearrange and write A1 plus A3 plus A5 plus A7. So there's 4 of these ones. So the sum of all the A1s So it's the sum of all the A1s is just going to be 6 factorial times that it can be 1, plus 6 factorial times it can be 2, plus 6 factorial times it can be 3, all the way up to 7. This is the total of all the A1s. But it's also the total of all the AKs, period, for each AK. Some of the AKs are added, some of them are not. So when I do this sum, it will be 6 factorial, and we'll do a big sum, 1 plus 2 plus 3 plus all the way up to plus 7, So these give me the values for all the A1s. 1 plus 2, all the way plus 7. This is me adding up just all the A3s together. And here we are adding up all the A5s. We're just choosing to add things in a different order. I'm adding all the A7s together rather than adding A1 minus A2 and so on for a specific permutation. I'm just adding up A1 overall permutations. And then it will be, well, I guess, so if I add up all the A2s, it will be the same expression, but minus, because it's minus the A2s. Then add up all the A3s, subtract off all the A4s, add up all the A5s, subtract off all the A6s, and then add up all the A7s. And all of that over 7 factorial. Okay. So, but now we can, once again, cancel everything out. This sum cancels out with this sum. This sum cancels out with this sum. This sum cancels out with this sum. And we're just left with this expression here. So my average is just going to be 6 factorial, 1 plus 2 plus 3, all the way up to plus 7 over 7 factorial. But these guys cancel out. And now it's 28 over 7, like I originally predicted. Okay. So there we go. That wasn't so bad. If you want another way to look at this problem and understand why everything's going to cancel out, notice that if I just take a look at this permutation, you know, the one that assigns I to AI, I can cancel this permutation out with just this permutation. So in some sense, for every permutation, we have an opposite that cancels out everywhere except A7. So when I add up these two permutations, I'm just left with 2 A7s. Okay? So that's another way to view the problem. We get 4 as the answer this way, but you know, maybe we'll just talk about this for a second. In general, we can get another permutation that, for any permutation like this, there's another permutation like this. Every permutation, there's a pair that is like this, and when we add them up, we just get 2 A7s. So how many pairs like this are there? Well, there's 5,040 over 2, because it's pairs, times 2 over A7. So we're really just adding up all the A7s possible, times 2 divided by 5,040 over 2. The 2's cancel out, and so once again, we're just adding up all the A7s and dividing it by 7 factorial. And this sum, as we've already talked about, is just 6 factorial like this. So there's another way to view the problem. So that's sort of 3 ways to do B part, which is not so bad. And either way, we get our answer of 4. 10/3 was our answer for A, and 6,700 was our answer for C. And that wraps up question 9. We got one more question to go, question number 10. I will see you guys for that one in the next video. Thank you for watching. Feel free to like and or subscribe, and I will see you as we finish up the Euclid contest for 2017 in the next video.